All right, I'm Mr. Ferguson, and here we are looking at the cell membrane. This is where it gets interesting. Now we're getting into the inner workings of the cell. Here we have the phospholipid bilayer, cell membrane. You can see it's composed mostly of the phospholipid. You're looking at the polar heads and the nonpolar tails. And again, they're arranged to where the tails are facing each other. This is the fluid mosaic model, so you can see it's fluid because the pieces move independently of one another, and it's mosaic because you have this kind of haphazard pattern of molecules that comprise the whole thing, the cell membrane. So let's go ahead and start with peripheral proteins. You've got peripheral proteins located on the outside and the inside of the cell, assuming this bottom part here is the inside of the cell. Outside of the cell, these can work as enzymes. They can join up, work together, help transport structures even inside the cell. Peripheral proteins on the inside, generally we're looking at, they can attach to cytoskeletons, other proteins that give the cell its structure and shape, gives it stability. Here we have a cholesterol molecule. This structure gives the cell its fluidity. It allows it to maintain a certain amount of movement. Here we have a glycoprotein and a glycolipid. These we'll consider for cell recognition. So they identify the cell as markers so that the cell is a part of you. And a lot of that has to do with the glyco part. They take on a certain shape. These are just sugars, but how they're arranged dictates if it's your cell versus some other cell, a cell that's not yours. Here we have an integral protein. We can just call this one a typical transmembrane protein. This allows structures inside the cell. And here's another integral protein or transmembrane protein, and we can call this one an aquaporin. This one would be specific for water and water that gets inside and outside of the cell. And I believe that is it for the cell membrane bilayer.